So, today we're going to be doing Unit 7, Solving Quadratic Equations, Lesson 4, Factors as Solutions. So, you'll see that there are other ways that we refer to factors in math when we find them as solutions. And you'll see them written in these several different ways. You'll see them known as zeros. You'll see them called solutions. You'll see them called x-intercepts. Or you'll also see them called roots, R-O-O-T-S. So those are the four common ways that we can refer to a solution to a graph, okay? And these all occur when we cross the x-axis, hence the name x-intercept, okay? So those all occur when we cross the x-axis. So as you can see right here, we have two solutions, zeros, roots, x-intercepts. So they all mean the same thing. They're just different reference points for these things. So does anybody have any questions about that?
Yeah.
Zach, don't tip back in your chair.
Miss.
Yeah.
It's not like really a question. I was just wondering though, like, how many months do we have until school's over?
2.
About 2, almost exactly 2.
It's like 40-something days left.
Yeah.
All right. So this is a recap on the zero product property. So if the product of two quantities is 0, at least one of those quantities must be 0. So we use the zero product property as a method to solving different equations that are equal to 0 on one side. So that means that the product means what operation? Product means what? Multiplication. So when we talk about product, we are talking about the operation of multiplication. So that's just a reminder, okay? I'm talking about multiplication. So as you can see, what does it mean when two things are next to each other in math and there's no symbol between them? Yeah?
It's because the x and the x, they're going to be x squares.
No.
And then
Not quite that yet. We're not trying to multiply them. So let's go back for a second and think about what the question was. If there's no symbol, between two things, in math we imply it's what operation? Multiplication, like 4x is really 4 times x, right? So these are a product. These are what we call a product. So we take each of these products and we set each one equal to 0. So I take x minus 2 and I set it equal to 0. And I do x minus 9 and I set it equal to 0. And then my goal is to solve each one of these for x. So to do that, on this side I'm going to add 2 to both sides. That leaves me with x equals 2. And over here I'm also going to add 9 to both sides, which leaves me with x equals 9. So these are our two solutions to my equation, and we use the zero product property to find them. So you're just solving two one-step equations on that one. Anybody have any questions so far? All right, we're going to proceed with the same concepts on the next one. So as we can see, these are a product. I know they're a product because there's no symbol between them, right? We indicate with 2 parentheses next to each other, there's no symbol between them, that's a product, okay? So if these are a product, we can set each of these equal to 0 because
X is 5.
Yes. So the reason we can do this is because the equation is equal to 0. You can only use this property if the equation is equal to 0. So just be careful, always make sure you check that. And then we're going to solve each of these equations.
12.
Good.
This is easy.
Mm-hmm.
You're saying I know.
No, I know to do this one. I got both of them right.
Good job. So does anybody have any questions about this one so far? Is everybody ready to move on to number 3?
Yeah.
All right, number 3, we check and make sure that it's a product. There's no symbol between them. And we make sure that it's equal to 0, which it is, right? So from here, we are going to set each of these equal to what? What do we set them equal to, Jet? 0. So I'm gonna set
Yes.
each one equal to 0.
0.
And then your goal is gonna be to solve each one of these.
4.
So this one, I'm gonna add
5.
4 to both sides. Not 5.
No, that one's 4 and then the other one's 5.
It's not 5. Watch. Add 5 to both sides.
Hold that. It's 5.
We get 3x is equal to 5. Are we done solving for x?
No, you can,
So didn't you get like a 40 on the test, bro?
oh my,
Jet,
you
Jet,
cheated.
Jet.
No, it's like that.
Yes, so then we divide both sides by 3 because
Whoa.
how to reverse multiplication is with division. But this fraction doesn't reduce, so you just leave it as a fraction, okay? You just leave it as 5/3 because 3 doesn't go into 5, okay? So you're just going to leave it like that. Jet, you with us? Because you said you weren't sure about this one, so did you get it?
Yeah, I get it.
So why we have to divide by the 3?
Because it's the opposite of multiplication.
Correct. Yep, so don't rush through it because you want to make sure you hit all the steps, okay? So now, this one seems to throw people off, so I just want to make sure we really understand what's happening here. So, what operation exists between the x and the parentheses here?
Distinctive.
Oh my god.
When there's no symbol, what operation is it? Multiplication. So, when it's multiplication, and the end result is equal to 0, we can set each of those two products, the two pieces we multiplied, equal to 0. So, I'm going to set x equal to 0,
What?
and I'm going to set my other product equal to 0 as well. X plus 8 is equal to 0. So you set each one of those equal to 0. Now, what do you notice happens in this first equation? Do we have to solve anything? No, see how it's already solved for us, right? Are you guys, you got this? So, we set this equal to 0, and then we set this one equal to 0 also, and then we can solve it, right? So I subtract 8 on both sides, and that gives me x equals negative 8. So I have two solutions here, x equals 0 and x equals negative 8. So, does anyone have any questions about this one? So if you just have a plain x on the outside, you're going to get one answer to be x equals 0, okay? So is everyone ready to move into the next page of the notes? Okay. All right. So Jody was given a function, f of x is equal to x minus 1 times x plus 2, and she was asked to find the zeros. The answer she provided was x equals 1 and x equals 2. What was Jody's error? So when they tell you they want you to find the zeros, that means that you're going to take your equation and you're going to set it equal to 0. So when they ask you to find the zeros and you have a function like this, you're going to take it and set it equal to 0. Once we've done that, we're now ready to use the zero product property. Because why am I able to know that I use the zero product property here? Because I have what between these two? Nothing. Which means that that's a product. So I would set each of these equal to 0. And I would solve. And I'm going to get x equals 1. And over here I subtract. And I get x equals negative 2. So these are the two answers I got. Do these match the answers that Jody got?
No.
No, what was her error? Which one did she get wrong?
First one.
Oh, the second one.
The second one, right? We got a negative 2, she got a regular 2, right? So her error was that she added the 2 over instead of subtracting it, right? So she added,
2 instead of subtracting 2.
yes. So she didn't do her solving correctly. She added 2 instead of subtracting 2. Does everybody understand why she had to subtract 2 here instead of add it? Because that's how you would solve the equation, right? You have to do the opposite operation. So is everybody good with that one so far? Okay. How would you find the zeros of the function f of x is equal to 3 times x plus 5? So the first thing you do when they ask you to find zeros is you replace f of x or y. You're just going to take the equation and you're going to set it equal to 0. That's the first step you always want to do, okay? Now from here, I'm then going to find where the product is. So where does the product occur here? Between what and what? Good, the 3 in the parentheses. So that means that's where the product occurs. That's what I'm going to set each one equal to. So wherever that product occurs, you set each one equal to 0. Now here we have a problem. What do you notice is the problem with the first equation that we set up? Is it possible for 3 to be equal to 0? No. So this is what we call a null equation, okay? It doesn't have any meaning. So when you get an equation like this where the variables are gone and you have a false statement, you just reject it, okay? It's not a solution. And then on the other side, we can just go ahead and finish solving. And I get x equals negative 5. So the only answer to this equation is x equals negative 5. The other one got rejected because it's not possible. So is everybody ready to try number 7?
No.
So number 7 says, can you use the zero product property to find the zeros of the function f of x is equal to x plus 1 plus 2x minus 1. What do you think? Yes or no? So this is the zero product property, right? So in order to use it, we need to have a product, which is what operation? Good. Is that the operation that exists between the two binomials here? No. What operation is this? Addition, also known as sum, right? So is that the right operation to use for the zero product property? No. So the answer here is no. This is a sum, not a product. The only operation that you can use this property for is multiplication or product. So if it's anything but that between those two, you cannot use it. If it's subtraction or addition, you cannot use it. Do we have any questions about that so far?
What comes with the function?
Is everybody good to move on to the next?
No, not yet, not yet.
Okay. Alright, so moving on. How can you use the zero product property to solve the function 3x squared plus 9x is equal to 0? So, you can only use the zero product property if you have binomials that are multiplied together. But in this case, as you can see, we don't have any binomials. So we first are going to have to use our factoring skills. So, what can we factor out of both of these?
3.
Good, we can factor out a 3 and a what? They also have a what in common?
X.
An x. So I can factor out a 3x. And 3x squared divided by 3x, all we have left is the x. And then what is 9 divided by 3? 3. So we end up with this factored form. So that's just using the GCF, greatest common factor of 3x, which we've learned about in the last few lessons, right? The last unit. And then we would take each of these products. As you can see, we have a product. We have something on the outside times the binomial, or you can write it as two binomials as well, or a monomial and a binomial. And you would set each of these equal to 0, okay? And then from here, once you've set them equal to 0, you would just solve. So what would I do on this one? How would I solve that? Good. I would divide both sides by 3. And what is 0 divided by 3?
0.
0. And what would I do over here on this one? Subtract 3 on both sides. And that's going to give me x equals negative 3. Oh, jeez. Any questions about that? Everybody good with number 8?
Yeah.
Okay. So now we're going to move on to identifying solutions on the graph. The solutions to a quadratic are the x-intercepts. If you see a graph of a parabola, look for the x-intercepts.
10.
So, on
Oh,
this
no, it's
one,
9, my bad.
you're looking for where we cross the x-axis. That's the horizontal one. So as you can see, we cross it both here and here. I know it's a little bit tiny, but it's actually at x equals -3. And what's the other one at x equals what? Anyone know? 0. And here, how many times do you cross the axis right here?
0
Once.
times.
Just once. And for some reason, I just realized there's a little bit of an issue here. It's flipped around, but it's x equals 2.
By positive 2 and positive by 4.
Yeah, it's flipped. I just realized that when it was put the picture, and sometimes it does that on Word. Sorry about that. So yeah, the picture's just flipped around by accident, but the answer is x equals 2.
Turn around.
So
Singular, okay.
sometimes quadratics only
All the way around.
only intersect the x-axis once, twice, or never. And then what do you notice about number 11? Does this one cross the x-axis at all? No. So this one has no solution. As you can see, it doesn't cross the x-axis at all, meaning there is no solution. Alright, so I'm going to post